Once refrigerant piping is all connected, pressure testing is a really critical step to make sure there are no leaks. Some of the key equipment that John is using here is a Schrader core removal tool, a digital pressure gauge, and a tank of dry nitrogen with the proper regulator for the test pressure. John is using a Schrader core removal tool here. Removing the core makes evacuation easier and faster, and it also allows the digital pressure gauge that he'll attach to sense pressure in the system. The pressure test reg used here has relatively few fittings. This means lower risk of leaks from the test rig itself. Remove the Schrader core from the service port. Keep the core clean and dry. You'll reinstall it after you evacuate the system. Keep spare cores on hand so you can replace them if they get lost or if they get dirty.
And there's my core.
Make sure the right regulator is attached to the nitrogen tank. For this system, we'll be testing at around 600 psig, but this can vary with different systems and with different refrigerants. Connect the nitrogen hose to the core removal tool. Make sure all the connections are tight. The isolation valve is still closed. Attach the pressure gauge to the side port. Digital gauges are recommended. They have better resolution than analog gauges, and they make it easier to identify leaks.
So this digital pressure gauge communicates with my phone, and so I'm going to be able to observe and record this pressure test through my phone.
Open the isolation valve slowly to allow some nitrogen into the system. Close the valve when you reach around 150 psig. Give the system a couple minutes to stabilize. If there are no leaks, the pressure will hold steady. Checking for big leaks at this low pressure can save you some nitrogen if you do have a leak. If there is a leak, the pressure won't hold steady. If it's a bad leak, you may even hear hissing near the flare. If pressure is dropping but you're not sure where the leak is, spray flares with a leak test solution. Use an approved solution only, not just dish soap. If bubbles form and grow, you've found a leak.
So it looks like my 1/4-inch flare has a big leak on it here.
If you do find a leak, don't attempt to fix it by tightening the fitting. Cut off the defective flare and make a new one.
Really try and get these flares, these threads nice and dry so that whatever got on there doesn't affect the torque settings. So now we're going to repeat the pressure test. See if we do better this time. So it's holding steady right at 160.4, 160.5 psi.
If pressure holds at 100 or 150 psi, slowly bring the pressure up to 250 or 300 psi. Pause again to make sure the pressure holds. If it holds, bring the system up to the final test pressure.
Okay, and it's stabilizing at 615.7 psi.
If pressure is steady after 2 or 3 minutes, record the official start time and pressure. Apply leak test solution to all flares. Wait 5 or 10 minutes, then check every flare carefully for leaks. Use a camera or use an inspection mirror to see into tight spaces. Sometimes bubbles form when you first spray a fitting, but if new bubbles form or if any bubbles grow, you have a leak. Check manufacturer instructions for the pressure test duration. This system here is going to be tested for at least an hour. This may be a good time to work on wiring or other stuff, but check the pressure gauge and connections periodically. If indoor and outdoor temperatures are steady, pressures should remain constant to within a few tenths of a psi. If temperatures fluctuate or sun conditions change, your pressures will also change. That's one reason it's important to check for leaks with a few different methods. If pressure holds steady for the full time period, record the final time and pressure. Disconnect the nitrogen tank and open the isolation valve to release the nitrogen. Close the valve to keep air and moisture out until you're ready to start the evacuation.